live. Okay. So let's move this here. And now we should be live. So let me open up second screen to make sure that I can catch the chat. Cool. Okay. So I completed 2015 today. I had one last day remaining. So this is the first time that I actually finish a whole year. So I'll be going over the other ones as well when I get some time. But yeah, I want to get all the stars. But for now, let's read day 18 and see how we fare. Day 18, Snailfish. You descend into the ocean trench and encounter some snailfish. They say they saw the sleigh keys. They'll even tell you which direction the keys went if you help one of the smallest snailfish with his math homework. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is a pair, an ordered list of 2 elements. Each element of the pair can be either a regular number or another pair. Okay, pairs are written like that, okay, where x and y are the elements within the pair. Here are some example snailfish numbers, 1 snailfish number per line. This snailfish homework is about addition. To add 2 snailfish numbers, form a pair from the left and the right parameter of the addition operator. For example, 1,2 plus 3,4 becomes... Okay, so you encase them into another group. That's fine. Snailfish numbers must always be reduced, and the process of adding 2 snailfish numbers together can result in snailfish numbers that need to be reduced. To reduce a snailfish number, you must repeatedly do the first action in the list that applies to the snailfish number. Okay. If any pair is nested inside 4 pairs, the leftmost such pair explodes. Okay, not sure what that means, but let's see. If any regular number is 10 or greater, the leftmost such regular number splits. Okay. Once no action in the above list applies, the snailfish number is reduced. During reduction, at most 1 action applies, after which the process returns to the top of the list of actions. Okay, for example, if split produces a pair that meets the explode criteria, that pair explodes before other splits occur. Okay. To explode a pair, the pair's left value is added to the first regular number. Okay, I have such a hard time reading this, so I hope the explanations will make sense later. To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair, if any, and the pair's right value is added to the first regular number to the right of the exploding pair, if any. Exploding pairs will always consist of 2 regular numbers. Then the entire exploding pair is replaced with the number 0. Okay. Finally, some examples. Here are some examples of a single explode action. Okay. Let's see. Okay, so we have this one. I wonder why they didn't highlight this part, because this is also changed. Because as far as I can tell, this is changed by 0,9, because this 1 is completely removed. You have 2, 3, 4 here. Okay, let's see. So this is a pair. So the right part is removed. Okay. I have to read more because I still don't understand it. But I see what happens here. It's like they take this and they remove it. Then the 9 gets swapped to the right side and the left one becomes 0. So I wonder if that's... So here you have the same. Okay. Left value is added to the first regular number. Okay, to explode a pair's left value is added to the first regular number to the left of the exploding pair, if any. Okay. Okay, so in this case there is none to the left. Okay. Man, I wonder why they write it like that, because this nesting will always be encased with another nesting. So you can't have three nestings there. So in this case they say the pair's left value, which would be 9, is added to the first number to the left of the exploding pair, if any. Okay, so that would be none in this case. And the pair's right value is added to the first regular number to the right of the exploding pair. Okay. Then the X. Ah, okay, it goes to the side. Now I get it, okay. Whew, okay. That was really, really tough to click in my head for some reason. So what they say basically is, if there was a value here, the 9 would get added to that. This one gets added to this, and then this entire pair is replaced by a 0. When it's at the border, the left one just disappears and it doesn't do anything. Okay. So the same as what you have is what you see here. Like the 3 gets added to the 4, so this becomes a 7. There's none to the right, so that one gets removed and this whole thing becomes 0. Okay. That is such a bad way of explaining it, but it might just be me. So in this case, I can see this would be 7, this would be 3, and there's a 0 in the middle. So yeah, 7, 0, 3. Okay, I got it. Whew. Yeah. Okay, I understand now. Now the interesting bit is, if you store this as a string, these operations become fairly easy to do. If you store this as a real nesting, it becomes fairly tricky. But let's see. I think I will keep this as a string for now and see if it bites me in the ass later. Okay, so this is the explode. I can understand that one. Explode I got. I still don't know when we need to do the explode. I have to go back and read that, but I understand the explode. Let's see, to split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 rounded down, and the right one rounded up. Okay, that's easy. 5, 5, yeah, okay. Cool. That's also easy to do in string format, that is. Because you just replace in line. Let's see. Oh, pardon me. Here is the regular process of finding the reduced result. Okay, let me just... app look, I forgot to do that. Let's see. Here is the process of finding the reduced result of that plus the... Okay, that I need to... after addition. Okay. Okay, I'm really wondering what they're trying to do here because I don't understand. Let's see. Hi, I'm still struggling. Okay, good to hear. Maybe we can help each other later. So right now I've decided to go with just keep it as a string and process that. Part 2 will probably bite me in the ass, but I think that will be the easiest to do for now. I'm still trying to understand all the rules because I still don't understand what's happening here. I understand the process of explode and split, so I'm still reading to figure out when we need to do these things because so far I don't understand yet. Okay. So the process of finding the reduced result. After addition, so I wonder, okay, so they do this, you have two pairs and then you have the operation. So addition, that just adds another nesting level, it changes nothing, right? For basically this is, see, yeah, it's just another bracket and they're added inside. So you add another, you make it into another group. So you do open bracket, A, comma, B, close bracket, and then you had done the addition. That is fine. So for explode, is there no index or do you do every one of them? I wonder. Let's see. So for explode, is it always just the first one? So I from this explanation, I wonder why they target the first one. So maybe explosion always just targets the first entry or something. I don't know. We'll figure that out later. Because here they have multiple targets. Ah, that's maybe the grouping level. Is that true? Okay, yeah, that's probably the something about the targeting that determines this one is the one you need to do. So yeah, I'll need to go and read that later. Let's see, so for explode, they explode this part. So the 4 gets added to the left, but there's none there, so that becomes 0. The 3 gets added to the 7. So 4 becomes, the 3 gets added to the 4, so this becomes a 7, then this is replaced by 0. So that's what's happening here. I don't know why they highlighted this part though, because this didn't change. So the highlighting in this one is wrong, in my opinion. They should have highlighted this part actually. So I'm not sure. I think this is actually just a bug in the highlighting, from what I can tell. I might be wrong, but this seems to me that they should have highlighted this part, because this is actually what happened. Okay, so after explode, then they go and they have, okay. Ah, okay, they target the row above or something for this. Okay, so that's weird. So, okay, never mind. So for the next row, I think they're off by 1 for highlighting what they want to highlight. So then they explode again, and they take these two. Actually, they should highlight this whole part, but they don't. So then you get 8 and 7 is 15. This becomes 0, then 4 plus 9 is 13. So this is the changed part here. Actually, this is the whole pair. So yeah, I understand that one as well. Still don't know why we target this one though, so I have to figure that out later. Then they do a split. So the 15 gets split here, just fine. Another split. So they, now the highlighting is correct. They split this one. And then explode. They explode the same thing. Right? So the 7 goes to the 1, so this becomes 8. The 6 goes to the 0, so that becomes 6, and then this becomes 0. So, okay, I understand this. All of these I understand, I just don't know why you would do these actions. So that is what we have to figure out still. So I can write this out. So I can, if I know which to target, I can do these actions. So it's just addition, explode, and split. Doable. Okay. Let's see. Once no reduce actions apply, the Snailfish number that remains is the actual result of the addition operation. Okay. Your homework assignment involves adding up a list of Snailfish numbers, your puzzle input. The Snailfish numbers are each listed on separate line. Add the first Snailfish number and the second, and then add that result to the third, and then add the result to the fourth, and so on until all numbers in the list have been used once. Okay? Okay, so in this one I think addition just means create more groups for the first one. So that is fine. So you always add it behind. So yeah, I can do that. Final sum of this list is... Wait, what? Okay, so then they applied their... So I'll figure that out later. Okay, so you have this one. Slightly larger example. Final sum sure is found after adding up the above Snailfish numbers. Okay, so at least this one is cool. They have a good example here. So in my mind, this should just be why isn't this not here? This doesn't look like an addition in this case. Because there's probably some, they have to do the reduce functions, etc. Okay. To check whether it's the right answer, the Snailfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. The magnitude of a regular number is just that number. For example, 9,1 is 3 times 9 plus 2 times 1 is 29. Okay, 3%, okay. Okay. So you can just find and replace this if you do the final calculation. So that is fine. So basically you could write a regex that just takes like angle bracket, digit, comma, another digit, comma, find that, replace the value, put it back in and keep doing that until you find no more matches. A few magnitude examples. Yeah, sure. I think I got this. There are lots of parts to this, but that's fine. So, given this example homework assignment, the final sum is this and the magnitude of the sum is that, okay? So now I need to figure out back to the beginning. Add 2 cylinders and form a pair from the leftmost and right parameters of its addition operator. There's one problem: Snailfish numbers must always be reduced, and the process of adding 2 Snailfish numbers can result in Snailfish numbers that need to be reduced. Okay, so this is the rules part. Okay, let me see. Notepad. So this. So this is basically the addition. Just got to figure out the reduction rules. The strange part is that it didn't feel like this when I was looking at this example here. But yeah, it's true, it gets added like that. So yeah, okay, I will write that in a bit. Maybe I should just start writing code anyways. Let's just write some code already, because there are so many moving parts that we need to write a lot of stuff anyways, so we can already start writing some small parts. So I will do regexes later, not now. So much code from yesterday. I had fun yesterday. Let's just make a day 0 here and prepare this for the other days, and just say, okay, day 0, 0, 0. Okay. At least now I have something that I can copy for the other days. Let's see, day 18, close all but this. Program, let's start with this one. Okay, so string add string a string b. Okay, so that is easy. That is the addition part. So if we take this, and let's write a test for this, dictionary, string, let's just do string test is, come on, I should probably just write unit test, but yeah, 2 lines, no, 2 lines. And let's say const string expected cost, no, const string expected is this. For int I is 1, I smaller, test length, increment I. String result is test.first. Result is add test I, comma result. Console.writeLine. So let's see if you run this, and it still runs the wrong day. That is weird. Ah, I need to run the correct project. False. Great. So this one is added in reverse. Let's see. What did I do here? I need to switch these around because I need to add one to result. Okay. Okay, that's the first part. The adding. Woohoo! Bum, ba-dum, bum, bum. So let's find the rules for the other stuff first. Snailfish numbers must always be reduced, and the process of adding two snailfish numbers can result in snailfish number that need to be reduced. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. Okay. So then we need to, like, this is +1, -1. So 1, 2, 3, 4. Okay. And then we have our number. Okay. Okay, so we do string reduce. String value. Int level is 0. For each, no, for int I is 0, I smaller value dot length, increment I. Now the tricky part becomes when you start to shift stuff around, but let's see if we can get that. So char C, C is value I. If C equals dun, 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 dun. So if level, let's see, if level is 4, explode. And we need to do this until there are no explodes actually. So we probably need to have a string explode, string value. And this will be recursive. Right. I'm just wondering actually, if exploded, it needs to start again, probably. I wonder if it even needs to return. I think it can just be string. Okay, because they said they need to repeat this until it's no longer needed. And then we need to find actually if any number is 10 or greater, the leftmost number. So it's regular number splits. Okay. Let's see. First we need to get this explode logic in check. So let's see, int previous number. Bum, ba-dum, bum, bum. Let's see, previous number plus equals C, else if dun, 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 dun. Do we need to track this? Let me see. List int scene number number scene. Int number index. Do we need that actually? I don't think so. Okay, let me see. So now we have string. Do we need a string builder for simple additions like this? Maybe, who knows. Let's just set one up, string builder. sb.append C. So we can do while C is value plus plus I. Let's see, because value is a string. Not is comma, and say not is say, and let me just say hash set char non-number. Actually I could do the inverse. Number chars is new blah 0 1 2. Do this by char code, but this is just fine. Okay, so we do while contains. Okay. And otherwise we have boom, 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 boom. Otherwise we've moved the pointer here. Why is it complaining? Parentheses can be removed. Okay, I'm not sure why. Ah, okay, here. Okay, like this. Okay. We actually need to go back to make sure that this loop works. Pum, 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 pum. Let me see. Dun, 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 dun. And then we do numbers seen dot add as int dot parse sb dot toString sb dot clear. Okay, so now we keep track of all the numbers that we see. The thing is, this probably needs to be a function or a small action in this case. No, func string int readnum. Do we even need that to be a number? The thing is, you need to know if it's a pair or not. So you also need to know the next character that is seen. You want to peek at that. So let's see, we want to return char next int val. Let's just do that. Readnum is this. And then we put in this. We put the string builder, that's okay. We can put a char in, actually, to have the current char and not have to read that again. So we can do that like this. Okay. Not a couple to, yeah, that is fine. We keep the tracking int above this. We do it like this. So we work with that same number, that works. Okay. And then we do return C, comma, okay. In this case we have result. Int result is this. Right, and we do this, comma. Let me move this a bit like this, okay. Pom 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 pom. So else we can do just readnum, and this one will forward all the things. That will work. Pom 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 pom. So now we do in var num is readnum c. In this case, we need to actually read c ourselves. So we have c is value plus plus I. So many pointer changes here in the string. Okay, and then we do if num dot next is comma pair, else if num dot next is close single value, else should not happen because we can't have more than 4 levels. Okay. Throw new application exception. So let's see how many times that one gets gets thrown. Okay. So yeah, once we've done this, let's see. I wonder if we need to have the index of the numbers where we found them as well. Because we need to change those numbers. So this one could be a list of int val int index. All right. In this case, we do int num index is I. It's already incremented. Will it be I? I think so. So either that one or 1 minus 1. That one minus 1. Because it's reading that index. No, I think that should be the first one actually. Use of an unassigned. Okay. So now we have the number and the index in its string before it was altered, because of course after we change the string these numbers become invalid, but for now it will be okay. Because the one before we can find. Yeah, we can actually change the outer ones, then do an inner replace, and then we just start fresh again. So that's not that doesn't matter, because we only process one and then we start over again. Exploded. It's true. Not that it matters because we don't track that anymore. So let's just remove it. Dun, 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 dun. Okay. So let's see if this, if my logic here works. What do you do for? Can you explode? Okay. Any pair that is nested inside 4 pairs explodes. Okay. So if it's not a pair, no need to explode. That also means that there could be deeper nestings, because there might, no, you can never have, once you have a single pair, you can't have a nesting in that, so that's bullshit. Okay. Okay. So this is fine. Now we just need to do the actual exploding values. So here you have num. Okay, and then you do another one. Num b is read num. Let's see if number next is that. Then we do. Actually, we need to read the value. C is value plus I, and then we read that one as well, which is fine. And then we do So actually, besides this index, we also need to know because we know the index in the string, but we also need to know if there's one before that. So it's actually int occurrence index. Let me see. We could deduce that from this. Let me see. Because in this case we have numbers seen. If numbers seen that count larger than 2, we have a previous number we need to update. Okay. So let's see, that would be var previous is number seen, and this becomes numbers seen that count minus 2, right? Minus 3. Let's see, if there are 2 in there, you have 0 and 1. If you have 3 in there, count 3. We want to get count 0, so now you did minus 3. This will be the target for the left. And actually we need to keep looking. We need to keep looking ahead as well. Actually, once we hit here, we don't care at all. So we can do while I smaller. I can write a function for that. That might be cleaner. So let's see. We do for now, let's see. We can need to find the next number, right? So what we can do is next num. We don't care there. We don't care about that either. Let me see. So we don't have an input element, just an output. And we do while say is value plus plus I. Not, let's see. So an empty while loop. This will skip all the non-number chars, and then we can do this part. So we can say while plus plus I smaller than value dot length, and we do this, and we do if I smaller value dot length. And then we do this whole part, else return c comma -1. Use of unassigned assignment, okay. C equals, we don't care here. Let's see, we have that. So I really wonder if this will work. Yeah, let's see. And we don't need to do this either. We don't need to do this. Yeah, we can do that. We don't care. So here we do var next is next num. If next dot val larger equal to 0, we have a next number. And I need to know the index for that. So in this case, we want to return this. And then we can just do -1, So this one be int val, int index. So in this case, we return the value and the index. Okay, seems like my internet is having some issues, so sorry if the stream isn't super smooth. I can see buffering here. Let me see. Wow. Okay. So we have that. We have the next number. Okay. So we first need to do this one, by the way. So we go to, let me see. Count -2 index. So int before ex is this. And actually, I think this read num needs to return that part as well, so we don't have to look it up. So we do an int index as well, like this. That makes more sense, so that we don't have to look it up again. So then we can do value num.index. And this can actually become a larger string because it can go over the value. So then you do a value is value.substring 0, num.index plus the new value plus value.substring num index. And technically this could also be above the length, right? Plus num dot val.toString.length. Right? So this splices a new string. I could write it like this. Okay. Wait, this one is if we just have one after. Okay, let me make sure. Else, if you only have one before, this becomes the logic, and I need to calculate the what the value will be. So explode a is num dot plus prev.val. So explode a becomes that part, and let's do that here as well, because we need to do another substring for the second part if we find one. So that makes this nice and let's see. So string after is this, but we also need to do something inside of this. Let me see. Actually, we need to do this after because we need to reduce those brackets to. I just put a 1 there, a 0 there, right? Let me see. So you actually replace this whole thing by a 0. So you remove one layer of brackets there as well. So that needs to happen there. So this is actually the before, the previous one that we need to do. Let me see. So you have 3 parts. You have the previous number, update if any, replace pair with 0, and then you do replace next number update if any. Okay. So extracting the part will actually be this -1 to swallow the first bracket there. Then we have a 0. And then the second part will be this plus 1. to swallow the second bracket there. So this is just the this is just manipulating, removing the bracket there. But we also need to preserve this first part. So let's just do that. So we have string before is this, right? String after we have that, right? No, we need to have next dot index. No, not next num. We have val a and num b. Sorry, num b. I need to get my naming straight. Plus 1. Why is it complaining here? Value before is declared. Why? Here is value. Ah, okay. Not sure what I'm doing here. Let me fix that first. So we have before and after. So value would then become value is this. So you do before 0 after, right? But then we also need to update either the in front and after parts. So this is already something we can do here. And then we just need to either modify the parts there. So we will work on before and after, and this will be the final part here. So what we need to work on is if, let's see, if number is seen. So if you already seen one before, we need to work on the before part. So here we will modify that. And we can do those two independently. So let's see. If we don't have it before, we don't need to do anything. Same for the other one. If next number. Okay, so we have if number is seen, we have a previous number that we need to update. So make the value here. Let me see. So this would mean that before is this. In this case, we need before that substring, and then we have previous dot index. Then we do explode a, and then we do before that substring previous previous dot index plus the existing value length. So yeah, that would be this. So this augments the before number, and we need to do the same for this one, except we do it with after. And I don't think we need this part. So this becomes next, and in this case it's num b. So we have next. Yeah. So this should replace the after part. And let me see that I also target the after. So yeah, basically this should be the explode logic inline in the string, which was more work than I thought it would be. And this will repeat until there is no... so once it finds the first one, it will just stop. So that is good. Man, that's a big function already. Okay, let's see. So the thing is, we should probably say value is explode value. This will call itself as many times as they need to, and then stop calling itself. Okay, and then we need to have the part that if any regular number is 10 or greater, the leftmost such regular number splits. Let's see. So I wonder, right? If we do this and then do this, if a new pairing of 4 appears, if you do this again. During reduction, at most one action applies, after which the process returns to the top of the list of actions. Right, okay. So after this, we need to still do the explode. So okay, so in this case, you can just read num actually. That's too bad. Because I have this here. I'm just thinking, let's see, if the explode ever gets here. Bum, 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 bum. I'm just thinking if it's if I should combine the two. Like, you want to keep exploding and then do the find the number, but I have already got this nice function set up here to read a number, so it's a bit of a shame that I can't integrate those two, but you want to have them separate, right? So yeah, I'll just copy it for now. So basically next num was this logic. And that's what it needs to do here, actually. Let's see. Int I is 0. Char C is just a... well, we don't care. Okay. So we can start at -1 actually, because it starts incrementing, not even look at the value, because this assumes that we were already doing stuff before and reading things. String builder. So, while so far next is read next num, while next dot index not is -1 and next dot val smaller than 10. Next is next num. If next dot val larger or equal to 10, do something, and then we do reduce value. Right. So now we need to do the reduction. What was it? The split. Yeah, the split. Split. And after the split, you go back and then you try to find the next one. So that is fine. Hey Simon, welcome. Did you do today's one already? I'm still doing part one and implementing all the logic. So I've written a explode function, which is fun, and I've written the reduce function right now, which is a lot of work. So I can actually do value is reduce, actually, return value. So now I need to implement the split logic, which is kind of easy actually. Yes, I did it this morning. Okay, cool. So value dot is uppon, and then we do value dot substring 0 comma next dot index, and then we do angle bracket value dot substring next dot next index plus next dot val dot toString dot length. And here we do the both parts. So we do math dot floor next dot val divided by 2. Is that better? And this is math.seal. So that should be it. How long did it take you? Because I've been streaming for over an hour. I had a lot of issues just understanding the text. I had to follow it all, and I think I spent like 20 or 25 minutes just comprehending what needs to be done. So yeah. Okay, let me see. So I update value here, I pass it along, I get it back. That is fine. We keep doing this. I wonder how deep the stack gets when I do this. I probably need to finding the reduced result of this. Oh yeah, that's after an addition, you need to do that. Okay, so let's just do a test here and see if we can do this. I've thought of a better approach than I use, but there's no way I'm rewriting that again anytime soon. Yeah, I can understand that. It feels like a lot more work than it has to be. So let's do add. Took me ages. Yeah, I can understand that. So let's see. String added is this, and then we do string reduced is reduce added. Console.writeLine reduced. I should probably just write it out after each time. So this should write out every step. So let's just see what happens. Major errors probably, but yeah. Input string was not in a correct format. Cool. So in the index is off there. So we have 0 through 9 there. Is that okay? I wonder how deep in the looping it is right now. Call stack. Ah, there's been a few explodes and reduce. That's cool. Let me see. Okay, the first one, read num. Okay, let me see, call stack. Let me see. So we found this. That is weird. So we found this one, then we increment it and we find another one. Okay. So this in this case, let's see if in this case we found a level 5 nesting. Looks like you've also gone with straight string manipulation. Yeah, I think it's easier because of all the nestings, like finding the one that's previous. I don't know. It seemed to me like the easiest way to deal with like the before and after stuff, but yeah. I'm just wondering, because in this case we find, so 1, 2, 3, 4. Oh yeah, and then I need to swallow 1 to actually get that. So then we should say if C is right. Wait, where does num? Oh yeah, this one does read num. Dun, dun. I think it's something like this. Yeah. I probably should have this one here as well, because that should never happen. And that I get a comma. I need to make sure that I don't. Okay, before I start editing stuff, let me just let me take this back. What I can do is just if numchars contains C, then we do append, and otherwise it's just one that we have to swallow. Let me just check here. Wish I had thought of the easy way to parse this into a tree structure this morning, though, even though I hate walking trees. Yeah. So now we get an empty string, and I wonder at which index that was. 11, let me see. Quick watch, value dot substring 11. Oh, I have 7, 7 there. Okay. I really need to just start actually just... Let's just remove all of this and just step through it nice and easy because, yeah, I need to debug. I probably have an offset wrong somewhere. Okay. Let's see. So I can probably run till here or here. Actually, do we have numbers already? Numbers seen? No, not yet. Okay, that's fine. Okay. So C right now is a square bracket. So that is not good. Well, it is good because the next level would be, we need to make sure that it's that. Let me see. Yeah, see, so that already fails there. So if we hit 4, we need to actually expect an angle bracket. So that is not correct the way I wrote it there. So let me fix that. Boom, 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 boom. So let's see, if because this is what we need, and we need the one after that to not be another angle bracket. Then we can do this. And if we hit that scenario, then we should get that. Okay, so let's run till here first. Yeah, sure. Okay, and now we have number is 44. Wait, what? I don't like the watch of that. So next is a comma, val, and index. Okay. So if we do value.substring num.index, we should get the 4 there, right? Okay. So so far so good. Okay. Okay. So this will be the comma. Yeah, we swallowed that one. Haha. Let's see. So in this case, it will have still the comma here. So we need to I plus is 2 because we already know the comma and need to read the next one for this one. Okay, let me just go back. How did that happen? Okay, let me see. Now we have, okay, quick watch, index 7, it's okay. Value is 3, so we have value.substring num_b.index. Let's see. I have 21 extra tests in my test project from today. Yeah, I can imagine. Okay, so this one is also correct. But I also need to make sure. String before value. Is this correct? see. Watch. So we have a value in here. Add to watch. Yeah. So that is correct. That is the first explode done. Well, we still need to augment the second part. So you see, next num is value 4, index 10. That is good, I think. Haha. That's a good one. So now we need to int after start index is this. So we do after start index. So when we augment this one, we need to offset this. So yeah, that is correct. Explode before. So now this becomes 7, but we need to do int augmented after index is next.index minus after start index. That's something to take care of. Something that I didn't think of, so let me set next statement. Boom. Object reference that sets an instance of an object. Okay. Let me just run to here once more. So yeah. So we cut out the comma. Actually, we take the comma, then we add the 7, and then we do further. So yeah, okay. So now we should have this value. We don't have that one yet. Okay. Let's see what we did wrong. Because this should be the first explode. Ah, we have the whole thing twice. So that looks good. Wait, is there just okay, I think I have a right instead of right line somewhere. Okay. Okay. Got scared there for a sec. Okay, so let's run this once more. Okay. Okay, so the first explode works. And then we crash. But that's fine. Let's see. Should not happen because more than 4 levels. Okay. What did we get into? I also need to make sure that I decrease the level here from reading. Wait. What's our index? I is 4. What is value in this case? Let's see. Okay, let's see. Was my condition here to... Let's see. C is a 0. What was value? Yeah, okay, so it starts with the literal there instead of the next level. So this isn't really level 4 actually. Well, it's level 4, but there is no nesting here. So I should not care in this case. Let's, for now, just comment this out. Okay. So now we did another part. Oh no, that's still that part. Okay. Bum, bum, bum. It has comma 0 in there. So where is it reading from? Read num C. Ah, okay. So let's see. I could probably, because this one hit a, I wonder how it got there, by the way. So it did that, it read a num. Oh yeah, okay. So then it should hit this one and then go on to that one. So I should probably do C is value plus plus I. Like this. Okay, what do we have now? A square bracket and a 7. Okay. How did that happen? I'm really curious to see what happened here. Let's see. Because C was a comma. Okay, I should just stop trying to be clever. Just swallow this one and continue. Okay. Let me see. If you misunderstand the algorithm or are missing an edge case, it will come back to bite you today. Oh yeah, I'm sure of that one. I'm sure of that one. But so far I kinda like it, so let's see how far I get. So that is the next one. Still good. Still good. Okay. So here, let me see. So it didn't find an explode after this one. So let's check out why that is. In this case, I can write an empty thing that won't trigger anything. Okay, let's see. And I want to have a watch with the level up. I need to pull this up. Let's see. Watch. I can probably pull this to the side where the diagnostics hit that I never use anyways. Let's move it over to here. Okay, so level becomes 1. I should probably also add value.substring I. A value. Okay, I just wanted to have that one here. Okay, never mind. So we hit level 3, level 4, and now we're in level 4, but this isn't a pair. C is a 7. And our level is still 4. Then we go to level 3. Level 2. So this is level 4, but it's not the nesting in level 4. Let's see, my code doesn't seem so bad just reading it. Yeah, compared to mine right now, probably. Let me see. I'm just trying to see if there's a... Which would be the level that it splits out here? Is it in the end? Yeah, so this one should be level 7. So let's see, level 4. So let's see if it goes to there. Okay. Ah, okay. So now it's actually, it says level 5, but this could be the nesting of level 4. I should probably just trigger this for level 5, because technically it will always be like this, and then we need to make sure this one isn't another opening bracket. So I think this should be the case. Oh wow! Now it's done all sort of funky, funky stuff. Is it even still correct? Here it made 53. Wow. So that's not correct. So that one is interesting there. Let me see. Yeah, that should be right. Let's see. So we have the 15 with the 13 there. So this one is still correct. Right. This one is correct. And after that it should split that 15 into 6 and 3, but it moved on to 53. So let's see what happens there. That was interesting. Boom, boom. And I changed it to 5 because you need to be level 4, but there needs to be another nesting, so that would count it to 5. So where was our debug statement here? Okay, so now we want to trigger on this one. Okay. Let's see what it thinks it needs to do. Let's run it like this. Okay, so it decided no action warranted. Cool. Wait, what? Ah, it should stop processing here actually. It needs to stop. That's an interesting one. Let me see if I can fix that. I wonder why I didn't notice that before. Let's see what happens when I run it now. Okay. More sane. Woo! Huh. Scared me there for a bit. So now the test case works. Wait, what? Ah, okay. So these are the additions in turn that we need to do. Okay, let's make this the test case. Kind of digging it now. It's like the old A-team thing. I love it when a plan comes together. Let's see if we can get the correct output here, but yeah. The final sum is found. Okay, so this is the expected answer. So let's see what happens when we run this puppy. Ah, it's not correct. Ah, okay. I'm so smart. The result is reduce result. Now part 3 of part 1. Yeah. Let's see. Is there a reason you don't use the VS feature to pin the debug values alongside the code? I don't know. This is Visual Studio 2019, I think. So I don't know. I need to still update to the last one. Let's see. Okay, so let's run this again. True! It worked! One shot, and it worked. Woohoo! So let's see the puzzle input. Ah, and then I still need to do that last part. The whole magnification, the magnitude thing. Damn it! I need to do that still, but okay. Let's do that as well. It's starting to feel like pain now, but I mean, it works and it's fast, and I've debugged all the errors out of it, so that's cool. The magnitude of the final sum. Okay, and then we need to find the deepest one. If you hover when debugging on the variable, it has a pin on it. Ah, okay. Yeah, it's probably was introduced. So I've been doing this since like the first betas of .NET since 2001, like December 2001. So sometimes I don't pick up on new functions that are introduced in the Visual Studio. So it might just be something that wasn't available for me for a very long time. So I didn't get used to actually using that. So that might be the case. Okay, so now we do our regular expression thing that I talked about in the beginning. So let's do string pattern is, and we do an accolade, and we escape this, and we do a, come on, d plus, comma, d plus, like this. We do AB, and B, regex, pair. Regex is new blah pattern regex option dot compiled. Why doesn't it like this? What? Okay. Static read only, blah. It's really useful, even changes color when the value changes. Ah, that's cool. I should use that. Where do we put this? Let's just put a function here, says int, I learned from my mistake, ulong get magnitude string value match var m is regex.match value while m.success. Int b is int but ulong. Let's just keep everything ulong, so don't have to worry about that later. .parse, and that's just my coffee machine going off in the background. So I've been coding for a long time when I hear that. Let's see, ulong.parse m.groups a.value, and we do the same for b. Okay. Let's see. Old string. Replacements is blah. Do the name of the extension. I think he means that it's actually just built in when you hover. So we'll try that later. Let me see. I can just do a regex replace actually. And that's actually what I should do. Let's just do that. Let's see. Let me just do it the way that I know right now, because that will be a problem. Because I need to have to calculate it on the values. So let me just check. It was ×3 and ×2, I think, right? The first one is ×3, another one is ×2. Okay. So we do 3 times that, and this will become 2 times this. And then you sum it up. Okay, so we can just actually do a string. We can do value is value dot replace ambient. I wonder. It's actually like the first captures, right? Captures 0.value because it's the full. Oh no, actually I don't have a full capture here. Doesn't matter. I can just do this. Okay, sorry if I'm a bit off right now, but it's yeah. So we do A is this, B is this, string AB. Plus, this is just B in this case. 2 times like this. A. Let me just do it like this. And then we do bum, 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 bum. And then we replace this one and you go back. So this one is on the first pair, and then if there's just multiple newer lower levels, it will work, and it will just keep shrinking down the deepest levels that it finds. Boom, 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 boom. And in the end, there will be just, the string should just be a raw number. So we do return ulong.parse value. So let me just do this. Ulong result is magnitude is this result. Console.writeLine. I can actually just do this here. Okay, so let's see if this works. I should probably remove all the console write lines by now. But yeah, let's just spam the screen once more, and then we have an exception. Nope, we have an infinite loop. Cool. Let's see. So what is this part? Quick watch. We have 8,7 and it doesn't exist in here. And we need to do I'm an idiot, it's m.nextMatch to move on. Okay, sorry for that, that was just stupid on my part. So now we should have a empty string of a stripped string that is just the values. So 3488. Let's see if that's also the answer. Yes, 3488. So I think that we are ready. I think that we're ready to process the real deal here. So we don't know the expected yet, so let me just do this. For parts is input dot 2 lines, and then we do this part. I need to clean this up sometimes, but yeah, still liking what I've done so far. But let's see. Okay, so let's see. Boom, 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 boom. So much processing, so much spamming to the console, and we end with 4202. Boom! One shot. Yeah. Okay, that's nice. Let's see part 2. You notice a second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the Snailfish numbers? Do I understand this question? Note that Snailfish addition is not commutative. That is, x plus y and y plus x can produce different results. Again, considering the last homework assignment above, the largest magnitude of the sum of any 2 Snailfish numbers in this list is 3993. This is the magnitude of... Let's see. Okay. Sorry for that. How long was it silent? I've been talking so much. That's the drawback of having a wireless mic. It's great when you can walk around, but I just sit at my desk, so I should probably, yeah, do something about that. But thanks for letting me know. I was just talking about that I need to remove all the testing stuff. And the actual input is fairly large, but it takes 11 milliseconds to do one pass. So what I need to do is get the permutations. I think I did that. I think I know what it is. Let me switch over. Properties. Okay. I switch to my test. See, this does nothing. Okay. I switch over to my webcam mic now. Is this also okay? So, Null G, by the way, thank you for joining me. So now we do, let's see, permutation will be an item. Okay. So we can do for each var pair in this. Actually, I could do a parallel for each. So let's see how fast this can go. Boom, 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 boom. It's good. Okay. Let's see. Pair dot item one. Result is this, and then we do get magnitude result. So these are the steps, and we need to have the larger magnitude, right? Okay. So we can keep track of that as well. So we do u long biggest is 0. If mag larger than biggest is mag. I think I'll go back and speed up my code at some point. I went the easy way rather than optimizing it for speed. Okay. Static object. I can just do object. Lock is my. Okay, and then we can do console.writeLine. Okay, so this should be part 2. Okay. Boom! Easy as pie. Yeah, that one was cool. I was really lucky to have like the permutation code already there, because that's a pain to write from scratch, just wrapping your head around that. So yeah, in this case it's just a matter of executing all the combos and then seeing which one is the biggest. So 27 milliseconds, it's not that fast, but fast enough, I think. So yeah, we've officially crossed the 1 second mark for all days together now. I can probably optimize it further, but or you can just use math.max. For what? Because I don't store the values here somewhere. Or do you mean math.max is thread safe, so you cannot overwrite? I don't know. What do you mean by just use math.max? So you solved it purely based on strings? I actually parsed the numbers. No, I also parsed the numbers. Well, yeah. So what I did was, I can walk through it a bit. So let me see. For the magnitude part, checking the biggest takes the two values. Yeah, I know, but in this case they are processed in parallel, and you don't have you don't want to like, why did I wrote it like this? Because it's multi-threaded. You want to make sure that you don't have a race condition where you override, so it's easier to just check and then enter a log. Yeah, but that way you override the value every time. So it's I think it's better to do it this way. Because there could be two parallel executions of those, and depending on how things are scheduled, I think you could enter a position where you override the biggest with a lower value because it's executing in multiple threads. So let's see. So I actually parse the numbers for some parts, but I did the whole code based on string manipulation. So let me see. I have this next num and read num, and this one just reads characters and parses them and keeps track of them. So there's a number scene that has a value and an index, because you have to do math with them at some point. You have to add and split, etc. So yeah, I wrote a parser that gets out the numbers, but it uses it in string form for most of the parts. So yeah, if there's any questions, feel free to ask, and I'll dive into it. Yeah, you luck once the check hits. You lock only once the check hits. Yes. Yeah, that's what I do here. So in this one, I check, then I lock, then I make sure that nothing changed while entering the lock. So I can do another check to make sure that nothing has changed while entering the lock, and then I override it. Let's see, my code is both similar and dissimilar to yours today. Yeah, I can check it out. GitHub. I use indexes rather than substring. What do you mean? I'll read the code and see what you did. If anybody else wants to share, feel free. Let's see, solutions 2018. So let's see. Makes sense, yeah. So magnitude, reduce, if nested is 4 deep, explode, if number is larger than 10, split. Okay. So reduce, something changed is true. Okay, well, something changed. Explode, new output is not output. Okay. So this one is something that could be optimized because the string compare is probably less efficient than just returning a bool here if you want to optimize for speed. Let's see, new output is split output. Okay, so I assume this one also calls itself recursively. Oh. It doesn't. Okay, so you go here. Okay. So you could actually change this to just call itself recursively as I did. So then you don't have to do this check. Let's see. Okay, so let's go to the meat of the thing. Let's see, depth count is 0, last number start, last number end. Okay. Yeah, okay, I got it. Yeah, I kept track of more data that I needed to, but in my mind I was thinking of some of the things that could happen in part 4. So I was like, okay, if we already read up to the numbers that we see, why not keep like perfect information there? But you're right, for the solution of today, you didn't need to do what I did. Like, I keep way more information than you actually need there. But that was just because I was like, okay, I don't know what I'll need in the future. Let's just keep all the data that I can, if it's not extra work. But yeah, this is cleaner. Let's see. See, increase depth count, decrease depth count, that's all the same. Depth count larger than 4. Okay. Oh, okay. So this also like does a lot more work probably than just doing the substrings there. I'm not so sure. You have to time that. Let's see, right hand side, left hand side. The basic idea is the same. Let's see, last number start is null, last number end is null. Okay. I wish I'd realized it was just a JSON structure this morning. Could have used the parser to do a lot of work in truth. Yeah, you could use a JSON parser, that's true. But isn't this more fun? At least I like to do stuff the hard way sometimes. Actually, how did you do the magnitude? I didn't even think about that. I also use regex, yeah. I guess it's like the obvious approach, right? Much more fun, yeah. Oh, yeah, you just keep track of those. Yeah, that makes sense. You could. Yeah, doesn't matter. I went recursive though. Where? Ah, okay, here. Yeah, okay. Yeah, that doesn't matter. But you, that's the. So you did this one recursively, and you did the explode like in a while loop structure. And I did it the other way around. I did the the calc magnitude in a loop and explode recursively. So the split is fairly clean. I think I can't even remember how I wrote it. There's just so much code here, right? Reduce. Okay. It's not that much actually. Okay. Yep. Okay, I think we have very similar solutions actually. It's the the idea is the same. So yeah, I liked today's one. When I started reading it, I was like, oh my god, because none of this made sense to me. Because I've read like this condition, but it just didn't click yet. It really took me like getting all the way down here to see this, to understand this, and then they also messed up the highlighting of this. But that made me realize that I understand the problem, so that is good. So yeah, I really like this this idea. The whole magnitude thing was, I was like, why did they add that? Just to make it more complex, but they actually used that for part 2. To combine it with like the, how do you call it? I can't even think of the name again. I just added the extension. Permutations, that's it. To add a permutation problem. So yeah, I like it. I wonder what the rest of 2001 has in store for us. 2001, here we talk. 2021. So yeah, I've had fun. So yeah, I think I'll end it here. And I'll hopefully see you guys again tomorrow. Let's see. I'm much slower than you, partially because I'm designing to be tested externally, and partially because I don't code that much anymore. But I'm not particularly fast, to be honest. Because this took me 2 hours. I'm sure this can be done way faster. I don't feel like I code stuff very fast, but I have fun doing it. It's like when I have Luc over and he's done it already, I'm like, don't tell me anything, I want to know nothing. I was like, I want to read the problem and just have it all work out in my brain. I like that the best, just like a clean slate, be surprised, try to figure out stuff, because actually the figuring out stuff and overcoming the challenges is most of the fun for me, right? And I really need to clean this up before tomorrow. But yeah, I've coded this up for like convenience. I don't know if I shared this before, but I wrote like a tool to read the secure cookie from your Chrome browser. So I logged in with Chrome here, and how this works is that they have a secure cookie that is like that gets passed along in a header, and that is what gives you your unique input, etc. So I wrote code to extract that secure cookie from Chrome, dump it to a file, and then this part here actually downloads the file into a cache, so that whenever I have like the solution base, it just has the .input, and this one will have the file. It downloads the input for me and cache it on disk, so that I don't have to re-download it again. And same with like the extensions. I try to code it for convenience and then fun. So yeah, I should probably build this into a more test-friendly thing, because what I always do is just paste in the test values and let's see, I have this cookie set up in my Blazor app. Yeah, lots of people do it, but I actually thought it was cool to programmatically read it from Chrome, because the whole term like secure cookie makes it seem like that's not possible, but you can do it. So that's pretty cool. At least I think it's cool. But yeah, I don't set this up for testing, and I actually write some test code as we go along just to validate the parts. But I could do with some unit tests there. Okay, I'll maybe do some like a small video on it or something and release the code so that people can use that as well. So it's something for the future. But I have so many stuff, so much stuff that I still want to do. Let's see, I don't have any way of reading it though. I added manually. I already read that. Okay. So yeah, it was a fun one again today. I quite like this challenge after first having like a headache of reading it. Actually implementing it, and yeah, it was fun. Did anybody do the 2015 one, by the way? I just completed the last day That was also quite fun. If you haven't done that, I can really recommend that one. At least it gave me a nice challenge, and I don't have internet anymore, so I think my internet is dying. I have 100 tests set up from this year so far. I should probably refactor and write some of those as well. So that was this problem. So like they have 1 and then 2, 3, 4, 5, 6, 7, 8, 9, 10. That was also, at least I thought that was really fun to work out, because I didn't do something like that before. But then I got to this table and I couldn't even understand it. I started this, 4 days left to go. Ah, cool. So yeah, I wrote something to calculate, like, to get, if I say like, okay, where does number 2000 end up, to calculate which x and y that would be and stuff like that. There's probably a formula for it, but Noel G says, I wrote a bunch of unit tests trying to wrap my hand around it. Today's puzzle had a lot of cases in the examples. Yeah. But it's also like, when you work with the strings directly, just being one index off somewhere just causes everything to trash. So it's really, you have to make sure that every assumption that you do and every change, that it really works well. Okay, I can probably keep talking for a few more hours, but I think we need to end it here and save some for tomorrow. So yeah, I want to thank everybody for stopping by. If you're not subscribed yet, it would be cool if you would sub, because I'm trying to hit like 1000 and the 4000 watch hours. So if you're trying to go to sleep, watch one of the Advent of Code playlists and give me some extra watch hours. So that would be nice. Top row is triangular numbers again. Yeah. So it's like +1, +2, +3, etc. Yeah, that's correct. Okay, so yeah, I'm gonna click the end stream button now. So thanks everybody for coming back and keeping me company, and hopefully see you tomorrow. Bye bye.